Let us discuss their oxides. Let us discuss first oxides of fluorine. We will not call them oxide, we will call them oxyfluorides, because fluorine is more electronegative than oxygen, and it forms two types of oxides, OF2 and O2F2. So it's like this, out of which this is more stable at room temperature. All these oxyfluorides, both of these are very strong fluorinating and oxidizing agent. That is why this OF2 is mainly used for the enrichment of plutonium ore, which is basically used in the nuclear as a nuclear fuel. It forms PuF6 and O2, which later on gives pure plutonium. So that is how these are used. And remember, these are not called oxide, these are called oxyfluorides, because fluorine is more electronegative than oxygen. And these are the two only compounds in which oxygen is also existing in their +2 and +1 oxidation states. Then let us discuss oxides of chlorine, bromine and iodine. What we need to know, generally we say that oxides of all of these four halogens are unstable. Mainly it is because of the very unstable or very weak OX bond strength. Then let us discuss oxides of chlorine, bromine and iodine. See, chloride forms number of oxides like Cl2O, Cl2O6, Cl2O7 and ClO2. Similarly, bromine also forms number of oxides like Br2O, Br2O, it's like BrO2, BrO3, it's like this. Iodine also forms number of oxides like I2O4, I2O5, I2O7. So it's like this. Now what we need to know is this, that the stability of these oxides is very different. It's like iodine oxides are most stable, followed by chlorine and then bromine. The least stable oxides are of bromine, and it's basically because of the middle row anomaly, the poor screening of the 4s and 4p electrons by the 3d inner 3d due to the 3d electrons, and as a result, due to the middle row anomaly, the oxides of bromine are least stable. But iodine and chlorine are very stable in comparison to bromine, are stable. They all are very good oxidizing and agents, and therefore they are used as oxidizing and bleaching agents. Like mainly the oxides of chlorine are used as oxidizing and bleaching agents in paper pulp industries and in other, as in laundries, etc. And out of these, ClO2 is the one which is mainly used for this purpose. And iodine oxides again are very important. Like they can be used in the quantitative estimation of carbon monoxide. Like if I treat I2O4 with CO, it forms what? Iodine and CO2. This iodine is then quantitatively estimated by titration with sodium thiosulfate. So this is how the oxides of iodine are used in the quantitative estimation of carbon monoxide in any air or gaseous sample. So these are their oxides. Now let us discuss their further compounds with metals. Compounds with metals. Now with metals they form the halides like Mx or Mx2, or it can be Mx4 like this, etc. What we need to know is this, that with fluorine mostly the metal halides are in highest oxidation states, and with chlorine, bromine and iodine they can be in their intermediate or in the lower states. The highest oxidation state ones are more covalent, whereas the lower oxidation state will be more ionic. That is how we can know this. Then let us discuss their halides. Yes, halogens, halides. It sounds very strange, but yet it is there. Halogens, halides are studied in the topic interhalogen compounds, because they on their own they react with each other and forms compounds which are called interhalogen compounds, which we will take it in a very separate topic later on.